Hello guys. Welcome to our channel, Makaut Engineering Information. We hope you all are doing well. Today's video is gonna be about data structures and algorithms in computer science and engineering. So let's get right into the video. If you don't subscribe to our channel, please subscribe and share the past videos and new upcoming videos. Let's start. Data structures and algorithms are a critical part of a computer science education, though not something that most boot camps graduates or self-taught people will know very well. This guide will serve as an introduction to data structures and algorithms, especially for those who do not have formal education in space. Mastering data structures and algorithms are key to becoming a successful software engineer. Learn more about data structures and algorithms in this comprehensive guide. What are data structures and algorithms? A data structure is a method of organizing data in a virtual system. Think of sequences of numbers or tables of data. These are both well-defined data structures. An algorithm is a sequence of steps executed by a computer that takes an input and transforms it into a target output. Together, data structures and algorithms combine and allow programmers to build whatever computer programs they'd like. Deep study into data structures and algorithms ensures well-optimized and efficient code. How do data structures and algorithms work together? There are many algorithms for different purposes. They interact with different data structures in the same computational complexity scale. Think of algorithms as dynamic underlying pieces that interact with static data structures. The way data is expressed in code is flexible. Once you understand how algorithms are built, you can generalize across different programming languages. In a sense, it's a bit like knowing how a related family of languages works syntactically. Once you glimpse the fundamental rules behind programming languages and their organizing principles, you can more easily switch between the different languages and learn each faster. Common data structures and algorithms. Common data structures you'll see across different programming languages include linked lists, stacks, queues, sets, maps, hash tables, search trees. Each of these has its own computational complexity for associated functions like adding items and finding aggregate measures such as the mean for the underlying data structure. Some common categories of algorithms are search, sorting, graph tree, traversing, dynamic programming, hashing and regex, string pattern matching. How do you learn data structures and algorithms? It's important to learn data structures and algorithms properly so you can understand the organizing principles behind web development and programming work. Follow these steps to ensure your learning is as efficient as your algorithms will be. Gradually move beyond HTML, CSS to a programming language. Python is good because it's versatile and can be used for many programming paradigms, and has more elegant syntax than JavaScript. Eventually, you'll work towards defining your own data structures and algorithms. Get familiar with computational complexity. In particular, big O notation and the different scales of time and space that represent the worst-case scenarios for your algorithms, from input to output, from linear, polynomial, exponential to logarithmic time scales. These scales will have dramatic differences in the performance and expected computation times of your algorithms. Something that might be logarithmic might scale decently well with large data sets and inputs, while something that is exponential may never finish in time. Understand different data structures and algorithm types. Read through basic data structure and algorithm types to get a better feel for the subject. Practice, practice, practice. Practice implementing algorithmic principles and actual algorithms and data structures with different exercises. Build your own programs. Get on-the-job training. Get a job in software engineering or a role where data structures and algorithms are implemented in order to best exercise your new knowledge.